Hello everyone. Today we are going to be solving equations with simplifying. So we're going to add a little bit of extra to our solving equations that we did with distributing, and we're going to have some collecting of like terms. So we might have some distributing, but we also are going to collect like terms. So that's something we need to discuss. So here's our first problem. 8x plus 7 minus 4x equals negative 13. So hopefully we have somewhere in our brain the idea of collecting like terms, but if we're a little rusty, that's okay. Let's go over it. On the left-hand side of my equation, I have three different terms, and I'm going to box them so it's easy to see. So my first term is an 8x. My next term is a plus 7. And my next term is a minus 4x. So I want you to notice a couple of things. This plus sign belongs to the 7 that it's in front of, and this minus sign belongs to the 4x that it's in front of. Terms are separated by plus and minus signs. Now we can collect like terms, which means they have to have the same variable or lack of a variable. So this 8x and this minus 4x both have x's, so we can combine them. So if I think of 8x minus 4x, what I'm thinking is, what is 8 minus 4? Well, that is 4x's. And this 7 is the only number by itself. It is called a constant. So it is the only constant. So I'm just going to write that as my plus 7 equals negative 13. And now my problem looks much more like the ones that we have been doing previously. So I'm going to subtract 7 from both sides so that my 7 minus 7 is a 0. I'm going to have 4x equals negative 20. I'm going to divide both sides by 4, and I'm going to get my x equals negative 5 for my answer. So I had to do some combining like terms first. Okay, let's do another one with some more combining like terms. So if I look at this problem, I have quite a few different terms on the left-hand side. I have an x, I have a negative 3, I have a plus 2x, and I have a plus 12. So my like terms are going to be an x and a plus 2x because those both have the same variable, same letter. So x, also known as 1x, if there's no number in front, it means there's only one of them. 1x plus 2x is 3x's. My constants, my negative 3 plus 12. So if I think negative 3 plus 12, it's like I owe someone $3. I got $12 for maybe like mowing someone's lawn. I pay back my friend. I now have $9 left over. It equals 24. So I'm going to then subtract 9 from both sides. My 9 minus 9 is my 0. And I'm going to get that 3x equals 15. I'm going to divide both sides by 3, and I'm going to get x equals 5. Okay, on our next one, we're going to do some distributing and collecting of like terms. So we might have to combine those skills. If you see a problem that has distributing, which means you see parentheses, that's the first thing you need to deal with. So I'm going to multiply everything in the parentheses by 5. I'm going to get a 5x minus 5 plus x equals 1. Notice I did not multiply this x by the 5 because it's not in the parentheses, so it's not part of my distributing. My terms are a 5x, a minus 5, and a plus x. My like terms then are these 5x plus x, so 5x's plus an x is 6x's. My minus 5 is my only constant, only number by itself, so I'm just going to write it down there. And I'm going to first undo my addition and subtraction. So I'm going to add 5 to both sides so that those reduce to 0. 6x equals 6. I'm going to divide both sides by 6, and I'm going to get x equals 1. Okay, we're going to talk about some special cases you might come across today. This one, we have a fraction in front. Now, if you start thinking, okay, I see parentheses, I need to distribute, that's a very good thought. But then you start distributing, and while you can, it doesn't seem like it would be very friendly. Because if I wanted to multiply 1/3 times 5, what I'd be thinking in my head is what's 1/3 times 5, or what's 1/3 times 5 over 1? And that's 5 over 3. I'm going to now have this fraction within my problem. I'm also going to have a 1/3 x. this is not something that I necessarily want to deal with. And so I'm going to give you a little hint as to how you can actually deal with this. Since the only thing on the left-hand side is this distributing, and 1/3 is being multiplied by the parentheses, what I can actually do is get rid of that 1/3. So I'm going to divide both sides by 1/3. Now this looks a little interesting, this like 2 divided by 1/3. So I'm actually going to show you a slightly different way of doing this. So I needed to do 2 divided by 1/3. This is kind of like what I was saying, right? Well, if we think about division of fractions, I know this is somewhere in your brain too, instead of dividing, we multiply by the reciprocal. How many of y'all remember that word, reciprocal? That means that we're going to go 2 times, flip over the fraction, 3/1. That looks a lot more friendly. So 2, that's essentially just 2 times 3, which is 6. That's what's going on in our brain right now. What we are doing is we are multiplying both sides of the equation by the reciprocal of that fraction. There's that word again, reciprocal. The reciprocals, if you look at how this would be, the 3's cancel. So we don't even have anything in the front anymore. It's a 1. Multiplying things by 1, it just leaves it alone. So our equation now says x plus 5 equals 6. We have actually just eliminated the fraction. We don't have to worry about it anymore. We subtract 5 from both sides, and you're going to have x equals 1. That's just a small introduction. You're going to come across a problem like that on your assignment. I want you to give it a try. We will discuss that more if it's only slightly clear and understandable. So don't you worry, give it a try, see what you can do. One more type of problem that I want to go over. This one has some collecting like terms. On the left-hand side, I have a 7x, I have a plus 5, and I have a plus 4x. So if I combine like terms, 7x's plus 4x's makes 11x's. My 5 is my only constant, so I'm just going to leave that alone. I'm going to subtract 5 from both sides. I'm going to have 11x equals 12. If I want to get x by itself, I'm going to divide both sides by 11. But if you look at this problem and you think, well, what's 12 divided by 11? That's not a whole number. Most of the problems almost all the problems we've come across are whole numbers. This one's not. But this is why I want you to use the fraction bar whenever you divide both sides, because the acceptable answer for this is exactly as written, 12/11. So when you get into high school math, especially, if your answer is an improper fraction, that is absolutely okay. Now, if you want to turn it into a mixed number and ask yourself, how many times does 11 go into 12? That's fine. You can say, okay, there's 1. And how many is left over? 1/11. But I'm going to tell you right now, this is an absolutely acceptable answer. But that is why we use our fraction bar when dividing. If it doesn't end up being a whole number, you already have your answer right there. Your work gave you your answer. Okay, give all of those a try.